In this chapter, we're talking about solutions. Solutions are a specific type of mixture we call homogeneous. We'll begin by looking at some of the vocabulary. If you remember from earlier in the course, when if we have matter, which is what things are made of, and it was divided into two categories, pure substances, I'll just write pure, and mixtures. Now, how mixtures are formed are when we take two or more pure substances and we mix them together. And pure substances could either be elements or compounds. So when pure substances, when you have a single composition, but when we take those pure substances and mix them together, we get mixtures. And mixtures can have variable compositions, which we'll talk about later in this chapter. So if you look here, that's the definition, that it's composed of two or more pure substances. So we're just taking things and mixing them. So that's something that's not too foreign to us. So when we talk about mixtures, there's at least a couple or a few different categories. So the ones that we'll discuss in this class, where there's three of them that we'll be discussing. So there's something that's heterogeneous. And like its name or description implies, you're going to be able to see the different parts of the mixture. So this contains what we would say distinct regions. So look at the examples, and I tend to do a lot of food with this. But things like fruit salad, if you had a fruit salad, you can still see the different fruits that it's made of. Salt and pepper are different types of spice mixtures, and you can see that there's different things there. But you can even have solids like a granite countertop, which would be considered heterogeneous, because when we look at it, we can tell that there's more than one thing there. So that's something that's heterogeneous. So it's visual. You can see distinct regions, or you can see the different parts of the mixture. Now, a second type of mixture, and it's the one that this chapter is really based on, is homogeneous. So homogeneous mixtures are uniform. As a result, so what our observation would be is that it only looks like there's one substance. So there's no distinct regions. Even though there's more than one thing present, when we look at it with our eyes, it only looks like one thing. Now this is what we call a solution. So in this chapter, after the definitions, we really are predominantly talking about homogeneous mixtures. So you can think to yourself that when we talk about a solution, that is a mixture that is homogeneous. So it's mixing uniformly. These are not uncommon to us. Here's some examples. Sugar and tea, sweet tea. Salt in water, salt water. Or even a solid example would be something like 14 karat gold. That would be a alloy, or what we call a mixture of metals. Now, when you mix metals, you have to turn them into a molten state before you mix them, and then you mix them, and then you let them re-solidify. So we can't just grind. If you just had some solids that you ground together, that would end up being heterogeneous because we couldn't get it mixed at a molecular level. And that is what homogeneous mixtures are. They're mixed at a very small level where our eyes can't see the difference. Where heterogeneous mixtures, I think of it like clumps. They have groups or larger quantities that are mixed side by side. Now the third type of mixture, which we'll talk again a little bit more later in the class, but this is a colloid. Kind of a funny word. And here, so observations, what we would see, colloids still look uniform. But in a colloid, the molecules are just a little bit larger. So what happens is when light goes through it, it's scattered. And that makes it have an opaque or cloudy look. So oftentimes we can tell something's a colloid because it looks like there's only one substance present, but we're unable to see through it because it's cloudy. Not because of the color. So like sweet tea has a dark color, so you may not be able to see through it simply because of the color, but it's not cloudy. It's a clear solution, so that makes it homogeneous. But colloids would look cloudy, so examples would be something like smoke, fog, or milk. These create something called the Tyndall Effect. The Tyndall Effect is when you shine a light through a colloid and you can see that light passing through the colloid. For example, if you've ever had an automobile or a flashlight and you're driving in fog and you can see the light scattered, a line of light through the fog. That's called the Tyndall Effect, and that's a characteristic of a colloid. So let's try to look at each of these different kinds of mixtures and see if we can classify it as either heterogeneous, homogeneous, or a colloid. I recommend that you pause it here and try to answer it first before I write the answers down. So remember, heterogeneous is mixed. I think of it, like I said, as like clumps, larger particles. So we see this has distinct regions. Homogeneous is going to be uniform. It's mixed at the molecular level. So it's going to look like one thing is present. And we anticipate it to be clear. And then colloids are also uniform, but they're going to have a cloudy effect. We're not necessarily going to be able to see through it because the particles are a little bit larger where they scatter the light. Now you sometimes also see suspensions discussed in mixtures, and in this textbook we don't discuss suspensions. In a suspension, the particles are even a little bit bigger, so they settle out of the solution when you let it stand there. So that's why, for example, medications given in suspensions, you have to shake first so that it's not separated. Now let's look. Letter A, bronze. So this is a solid. It's not a pure substance. Bronze is a mixture of metals, and mixtures of metals we call alloys. And alloys are homogeneous. Other alloys would be things like steel and 14-karat gold. Granola. So imagine granola, and you can see in the granola oats and nuts and maybe raisins. So you can see all these different things. When you can see the different parts of the mixture, we call that heterogeneous. Now, orange juice with pulp. Well, you might argue, this one I got out of the textbook, I suppose you could even think some orange juice looks like it's almost a colloid because it's cloudy. But I think when they write orange juice, if it was orange juice without pulp, I think they would say that was homogeneous. And then with pulp means you'll be able to see other things in it, so they're going to call this heterogeneous. Household ammonia, and this is actually an answer that could be almost any other cleaning supplies. So most cleaning supplies, household ammonia has water and ammonia in it, but it only looks just like a homogeneous, only one substance. So it would be considered homogeneous. Most of the cleaning supplies you find in the store would be considered homogeneous mixtures because they're uniform throughout. Gasoline is also a mixture. It would be homogeneous. We don't want our gasoline separating into different parts. And then fog, which is the classic colloid. So just remember your observations, and here you're trying to think of the observations, what you would expect to see in identifying these three types of mixtures. There's other vocabulary that we use with mixtures, and so let's take a look at this vocabulary, and then we'll answer a couple questions to see how we did with it. So when we're talking about a vocabulary, there's two components that we discuss in the vocabulary. There's the solute, which is the substance present in the smaller amount. This is usually what's being dissolved. And then there's the solvent, which is present in the larger amount. This is usually what's doing the dissolving. So for example, here's 2. If I had 10 grams of sugar and 50 grams of water, sugar is in a smaller amount than the water, so sugar is the solute and water is the solvent. As a general rule, when you mix a solid in a liquid, the solid is always the solute and the liquid is always the solvent. Now, always when you have 2 liquids, it's a little bit harder, and that's this next example. And so in this example, I have 10 milliliters of water and 50 milliliters of ethanol. So remember, the definition of the solute is it's in the lesser amount. So the 10 milliliters would be the solute, and the larger amount, the solvent, would be the 50 milliliters. Now, water is a very common solvent. And so when water is a solvent, we actually have a whole name for that, and that is an aqueous solution. So if something's an aqueous solution, all that means is that water is the solvent. Oftentimes in a chemical equation, you may see it written this way. So you'll have the formula of the compound, and then behind it, you'll say AQ. And that just means that it's aqueous, or water is its solvent. So let's look at some more definitions, and then we'll try to answer some questions about these definitions. So another thing about solutions is when you make a solution, sometimes they conduct electricity. A solution that conducts electricity is an electrolyte. And the reason it conducts electricity is because it has ions. So what happens is, when some solutions are made, some of the compounds dissociate or fall apart into ions, or they can do ionize, which means they react to form ions. And once they form ions, the electricity can travel on that ion, and so then it conducts electricity. So for things that will do this are ionic compounds, because ionic compounds dissociate into their ions. Remember, dissociate just means they kind of fall apart. So for example, if I had sodium chloride and I put it into solution, so let's say it's aqueous, I dissolve it in water, then it actually, in the solution, I would have sodium ions and chloride ions. And if I tested this for electrical conductance, I would find that it would conduct electricity because of the presence of the ions. Now, if I had something like calcium chloride, it would even break into more ions. You would still have the calcium, but it has 2 chlorines, so you'd have 2 chloride ions. It would also conduct electricity very well. We'll talk more about electrolytes when we talk about acids and bases, because you see here, acids and bases are also compounds that will ionize or dissociate to form ions in solution. So electrolytes conduct electricity because they have ions in their solution. We often associate electrolytes with things like Gatorade, the sports drink, and that's because our body has an electrical system which requires ions in it to help our muscles, for example, operate correctly. Now, when we think about vocabulary and we add prefixes to words, we would see here that I put the word non in front of it. So a non-electrolyte would mean it's not an electrolyte. So it does not conduct electricity. And the reason would be is it has no ions. So substances that have no ions are covalent compounds. Now that brings me back to the point of reminding ourselves how I distinguish between ionic and covalent, which was talked about earlier in the course. Ionic compounds, we can look at their formulas, and they have metals and nonmetals. So that's how I can decide that they're ionic. And covalent compounds, these things are what we call molecular, and they have nonmetals. So I can look at their formulas and distinguish if something is ionic or covalent by the types of molecules that they have. So now let's answer a couple of questions about the vocabulary on this page. I recommend that you pause here and then try to answer the questions before I do. So this question says, identify the solute and the solvent in the following solutions. So of course I would know if it's a solid and a liquid, then the solute is always the solid and the solvent is always the liquid. However, sometimes I have to use the basic definition, and that's the solute is the substance that's in the lesser amount, and the solvent is the substance that's in the greater amount. So I just look at the numbers. Here I have 10 grams of sodium chloride and 100 grams of water. So the 10 grams is the lesser, that's the solute, and the 100 grams is the greater, that's the solvent. On the second example, letter B, I have 50 milliliters of ethanol and 10 milliliters of water. So the 10 milliliters is the lesser amount, so that is the solute. And the 50 milliliters is the greater amount, so that's the solvent. On this example, I have 0.2 liters of oxygen and 0.8 liters of nitrogen. So then 0.2 liters is the lesser amount, so that's the solute. And the greater amount is 0.8, the nitrogen, so that's the solvent. One thing that's always true about mixtures of gases, for example, air, because of the properties of gases that they're so far apart and they have so much space in between them, they are always homogeneous. So anytime you have gases, they're always homogeneous. So for example, air is always going to be a homogeneous mixture. Now let's try to look at the definitions for electrolytes and non-electrolytes. So electrolytes conduct electricity, and why they conduct electricity is because they contain ions, and they can be things that are ionic compounds, acids, and bases. Now at this point in the course, we have not discussed acids and bases yet, so we'll look at those in the next chapter. And then non-electrolytes do not conduct electricity because they have no ions, and the type of substances that make mixtures that are non-electrolyte are covalent substances. So when we mix ionic substances and make a solution with water, those are electrolytes. And when we mix covalent substances, for example, in a solvent like water, those are non-electrolytes. So KCl is ionic because it has a metal and a nonmetal. So if I dissolve it in water, it's going to be an electrolyte. Sucrose, looking at the formula here, it's a form of sugar, and it has carbons, hydrogens, and oxygens, which are all nonmetals. That makes this covalent. So when I dissolve sucrose in water to make a solution, that solution would be a non-electrolyte. There will be no ions because covalent compounds do not dissociate to make ions. Now sodium nitrate, so here's a metal, sodium, and nonmetals, that makes this ionic. When you take an ionic substance and you dissolve it in water, it forms ions, and that makes that solution an electrolyte. So it would conduct electricity. And finally, methanol, which is the formula is right here. It's all carbons and hydrogens, which makes it covalent. If I make a solution and dissolve it in water, then I will have that solution will be a non-electrolyte because covalent compounds do not conduct electricity in water because there are no ions.